In this video, we're going to examine a slash 16 subnet mask applied to an IP address. In the last video, we did a slash 24. So if we go to slash 16 and we use fewer digits for the network, what do you think that's going to do with the amount of available addresses for the hosts? And hopefully you're thinking, well, that should be more addresses. But how much more? Well, let's take a look. So what we've got here is our address is 192.168.100.10, and our subnet mask this time is now 255.255.0.0. You can see the color scheme has changed a little bit. The golds are starting to gain on the reds. There's a little bit less red and a little bit more gold, because at this point on this system, what we've got here, and that is moving around, and I don't want that to do that. I want to do this. What on this system here is that this piece right here is now set for the network portion. So our network is now going to be over here, and our host portion is going to be these values over here. Now, how many digits does that now give us for our network? The answer is 16. We are the slash 16. And remember, that slash value always is listed as however many digits in the IP address you're going to use for the network portion. Great. And you can see there is 16 consecutive ones that are mapped to the first 16 digits of your IP address. So to be in the same network with this subnet mask, any given device would have to start with the same two decimal values of 192.168, because that is the bit pattern that I've explored right here in the first 16 digits. Great. Now, to be in the same network, what is the first possible address, or how big of this network is going to be? This is going to be a big, big network. So it's going to be a whole bunch of zeros and a whole bunch of ones and a lot of combinations. So if we look at the whole thing, we can see here that we've got 16 zeros in a row, which means that we can have any combination of 0 and 1 to be a host. So the lowest possible value we could achieve would be 16 zeros in a row. So that would be 1, 2, 4, 6, 7, 8 zeros, dot 1, 5, 6, 7, 8 zeros again, which is going to equal our lowest possible value would be 192.168.0.0, because that's the 8 zeros here is going to be 0, 8 zeros here is going to be 0. And so 192.168.0.0 is going to be the lowest possible address in this particular network. What's the highest possible address? Well, we're going to do the same thing that we've been doing. So we're going to say 1, 2, 3, 4, 5, 6, 7, 8. I'm going to say 8 ones in a row is going to equal 255. And 8 ones in a row is going to equal 255. And the highest possible address we can have in this particular network is going to be 192.168.255.255. Great. Okay, so what's our network ID going to be? So if I'm going to write my network ID in, I'm just going to put my network ID here. So write network ID is going to be 192.168.0.0, and my broadcast ID is going to be the highest possible addresses is 192.168.255.255. Every other combination of zeros and ones in that space of 16 digits for the host is a valuable host, is a usable host that you could use on a printer or a PC or a router interface or a switch's VLAN or whatever you want to put it on. You can use that. Now, how many total addresses is that? Well, it's a lot, right? So there's a couple different ways to figure this out. The first way we could figure it out is we could use exponents. We could say, well, that's 16 digits, so that's 2 to the 8th power plus 2 to the 8th power for both of these, which is going to equal 65,536. So that's one way you could do it. Or 2 to the 16th power is going to be 65,536. Another way you could do it is this: is you could say 256 in the third octet times every combination of zeros and ones in the fourth octet, which would also be 256, equals the same thing, 65,536 total unique combinations of zeros and ones in 16 binary digits. That's a big network. It's a much bigger network than what we just had with a slash 24. So we doubled the size of the host space, but we didn't just double the size of the network. We went from 256 total addresses in a network to 65,536 addresses in a network.